This video is going to be on factoring expressions that are quadratic in form. So before we start factoring them, let's just talk about what they would look like. So an expression that can be written as, I'll write it as a times u squared plus b times u plus c, where a, b, and c are real numbers and a doesn't equal 0. A can't equal 0 because if it did, then it wouldn't have the quadratic, wouldn't have that highest power of 2. Where u is an algebraic expression is called quadratic in form. So basically what we're saying is u is a placeholder for an algebraic expression. Sometimes it'll just be a single variable, sometimes it'll be something that has more than one term in it. But basically you can replace whatever that expression is with u to form something that looks like a quadratic expression or quadratic function, depending on what you're looking at. And we can talk about this as we would when we normally would factor once we get to this point. So the goal is to be able to rewrite it in this form and then factor it. The way you'll notice that you have this form is typically the power on the first part will be double that of the second term. So let's take a look at an example here. So if I said to factor y to the fourth minus y squared minus 6. First off, you should kind of recognize that it's not our typical quadratic because the highest power isn't 2. Remember, to be quadratic, the highest power is to be 2. So to be quadratic in form, we want to simplify this to show, or make a substitution to show that the highest power can be used as 2. So the way we notice this is that we see y to the fourth here and we see y squared, and we see this power is actually double this power. So what I can really do is write this as whatever this variable is to the power of 2. So y to the fourth is the same as saying y squared, whoever that was, to the second power, minus, we're going to keep this as y squared minus 6. And the reason we know this is that 4 divided by 2 gives us 2. So that's how you know that that's the power there. And then what we do is we say, okay, now let's make a substitution, so this actually becomes u squared. Well, what do? I have to replace the y squared with u. So I'm going to say let u equal y squared. Typically the easiest way to do that is to pick that middle variable and let u equal that. So then that'll be the same value here to the second power, because remember the powers are doubled. So we have y squared is going to be now rewritten as u. So this is going to actually be u replaces the y squared, and then that squared on the outside stays. That's where this squared is coming from. Minus y squared is u minus 6. So like I said, if we pick u to be the middle one, then this one will always be that to the second power. Once we have this, you would factor like you normally would. Typically we first look for a greatest common factor. In this case I don't see one. I notice I have 3 terms and I don't see a value in front of that u squared, so I can make 2 sets of parentheses right away. U squared means we want u times u for the first part. We want numbers that multiply to negative 6, right, and add to negative 1, just like we normally would. Multiply to the last term, add to the middle coefficient. Numbers that multiply to a negative 6 and add to negative 1, make sure you can find these. The numbers that do that would be a negative 3 and a positive 2, right? Negative 3 times 2 gives you a negative 6. Negative 3 plus 2 does give you a negative 1. Now, don't stop there, because remember the original problem was in terms of y. We have something in terms of u. So we get this in terms of y, now we back sub. So at this point, maybe I'll write it here so you know I'm doing it. You want to back sub u equals y squared. In other words, whenever you see a u, you're not going to put y squared, so we would have y squared minus 3 times here y squared plus 2. And then the last thing you want to do is note if either of these factors, because it factors further, then you'd have to factor if it does. In this case, it doesn't factor further. You see two terms in each of these factors, so you'd be either looking for the difference of perfect squares or the sum or difference of perfect cubes. In this case, you don't have either of those here, so that's it. You factored it, and then you're done. So you use this to replace expressions. Sometimes they're variables, sometimes they're expressions. Let's take a look at another one. If I said I had, maybe I'll do this on a new page just so we can see a little easier. If I said we had to factor two times in parentheses x plus 5 squared minus 5 times x plus 5 minus 12. And you want to be careful here, because I want to factor this. You might want to note to see if this is something that's factorable right away or if it's something that's in quadratic in form. What you don't want to do in this case is don't start distributing immediately. Sometimes people do that by mistake. And if you did, you could still get to the same answer. You could multiply x plus 5 times itself and distribute through and then simplify and then factor at the very end, but it'd be a lot more work. If you notice right away that this has that quadratic in form, right? The power on this expression is double that one in the middle, then you can make a substitution to rewrite this as something that's in quadratic form. So I'm going to let u equal, in this case, remember, you typically want to pick it to be whatever's in the middle because then u squared will be whatever's in the first part. So I'm going to let u equal x plus 5. And if I do that, I'm replacing the x plus 5s with u here. So this will be 2 times u is getting squared, right? Because x plus 5 is u, it's getting squared, minus 5 times u minus 12. Now once you're here, right, you can factor what you have left because now we have a quadratic expression. And you want to still look for the same things you normally would. Is there a greatest common factor? Well, in this case, no, there isn't. Right, and then after that, you want to ask yourself how many terms you see. We see 3 terms. If you have 3 terms, you want to look in front. Do I see a value in front of that u squared? In this case, yes, I do. So that either tells you want to use a trial and error or using an AC method. And maybe I'll use AC method just to kind of refresh your memory on how to use it. But trial and error would also work. It's your preference on how you want to approach this. If I was going to use AC method, remember you want things that multiply to what we call AC. Remember, A is the first coefficient, B is the middle, and then C is that constant at the end. So when I say multiply to AC, I mean multiply to things that are A times C, 2 times negative 12. So I really want things that multiply to a negative 24. And they also have to add to the middle coefficient, which is negative 5. Well, what values do this? Well, numbers that multiply to a negative 24 and add negative 5, negative 8 times a positive 3. You need to know your multiplication tables to know this, right? That gives you negative 24. Negative 8 plus 3, that does equal negative 5. So it checks out. These numbers are unique. Now remember what you're doing with them. This is the more important part. When you do AC method, it's a rewrite method of the middle term. It's a rewrite so we can try to use factoring by grouping. So 2u squared in the front stays the same. Minus 5u gets replaced with the minus 8 and the positive 3. And just make sure you know you're putting u after each of them because they're like terms. So it's minus 8u plus 3u minus 12 stays the same at the end. So right, I just replaced this middle part right here. Right, it's just rewriting in an equivalent form. Once you have that, when you have 4 terms, now you factor by grouping. Each group should have a GCF. The GCF of the first group, 2u squared minus 8u. 2 and 8 share a 2 in common. U squared and u share a u in common. 3u minus 12, the greatest common factor. Remember, you take the first sign, which is positive, so it's a positive 3. So when we factor these out, remember you're factoring them from each group of 2. So here I'm factoring out 2u. What's left? 2u squared factoring out 2u is the same as dividing it to figure out what's left in here. 2u squared divided by 2u is just u. Negative 8u divided by 2u is a negative 4. Close that parenthesis. This is a positive 3. That's a positive. This has to stay plus. Make sure you have it there. That sign matters. It gives you the operation later on. So plus. Factoring out a positive 3 here. 3u divided by 3 will give me u. Negative 12, factoring out the 3 gives me minus 4. Make sure you watch your signs. Now when you use AC method, you used factoring by grouping. When you do grouping, you're hoping that you have two terms with the same factor in it. In this case we do. These both share a factor of u minus 4, so you factor that to the front, and then whatever's left over when you factor it out from each term goes in the second set of parentheses. So this is 2u plus 3. Once you have that, right, you are not done, because remember, we're trying to solve for what? We're trying to evaluate this for x. Right now we have u, so what do? Same thing we did in the first question. We're going to back sub. So I'm going to back sub here with what I let u equal. U is equal to x plus 5. So you're going to replace the u's now with x plus 5. So for the first one, you'll have u gets replaced with x plus 5 minus 4. Close that parenthesis. We'll simplify this in a minute. In the second one, we have 2u. So this is 2 times, now make sure you put parentheses here because it's 2 times the entire x plus 5. And then that replaced u, and then we still have plus 3 at the end. Close the parenthesis. Here I didn't put parentheses around the x plus 5 because it wasn't being multiplied to anything. And now we're going to simplify the inside of these factors. So x plus 5 minus 4 will be x plus just 1. In the second factor, make sure you have the parentheses there. 2 times x plus 5 plus 3, you're going to distribute 2 in. You would have 2 times x is 2x, 2 times 5 is a positive 10, plus 3, and then we're going to combine like terms. So we have x plus 1 times, this is 2x, plus 10 plus 3 is plus 13. Now if either of these factored any further, you would factor further. In this case, neither of them do. So that's it, you finish the problem. So this original 2 times x plus 5 squared minus 5 times x plus 5 minus 12 factors down actually to x plus 1 times 2x plus 13. Sometimes we'll get thrown off by that. It doesn't look the same, right? If you had expanded this at the very beginning, you would have gotten down to something that you could factor to get you to here, but it might take a little bit longer to get there that way. So quadratic in form, typically you want to make a substitution and then factor from there. Let's do one more together just to make sure we see it. If I said to factor, let's take a look at, we'll do 3z to the 4th minus 17z squared minus 28. So first thing you should notice, this is quadratic in form. If I had a GCF, you'd want to factor it out. In this case, we don't. This is quadratic in form because the power on that first term is double that of the second. And that means I can use a substitution to factor this easier. So we'll let u equal, what do you think it should be? It should be, remember I said always pick the middle one, because if this is double this, then the way we write this is squares if we pick the middle. So I'm going to pick u equal z squared. And then thinking about how this is 3 times z to the 4th is really z squared squared. That's why we're allowed to do it. 4 divided by 2 gives me that 2. Minus 17z squared minus 28. And now I'll make the substitution here. So this gives me 3, the z squared on the inside is going to replace with u, so 3u squared minus 17u minus 28. Now once we've done this, we want to factor this. We can factor this with an AC method or a trial and error. It's your choice. In this case, maybe we want to do a trial and error just so you can see it. So if I was to do this by trial and error, rather than the AC method, you make 2 sets of parentheses right away. For 3u squared, you want to multiply to 3, so we know the coefficients here are 3 and 1. 3u squared, you want u times u. So I know for the first part, remember this comes from undoing FOIL, like reverse foiling. 3u times u gives me the 3u squared. It's the only way we can get that from factoring. So I know it's 3u and u. To fill in for the other parts of these factors, you want things that multiply to negative 28. Now you don't want to just say adds a negative 17. What you really want to say is it's multiplied to negative 28, and then when you try the trial and error part, when you're testing the middle terms, they should combine to give you a negative 17u. In other words, when you're testing the middle terms and you FOIL. Well, what are some factors of 28? Well, 28, you're either going to pick 1 and 28. You got 2 and 14, and 4 and 7. Right, those are some of our choices. They pair up to get to a negative 28, so one has to be positive, one has to be negative. you know, 28 seems too large to fit into either of these to get us to a 17, because the other one would just be a 1 or a 3. The 2 and 14, that could show some potential, but the 4 and 7 are actually what's going to work here. If I pick this to be 3u, and then I put the positive with the 4, and then minus 7, because 3u times negative 7 gives me negative 21. Positive 4 times u gives me a positive 4u, so 3u times negative 7, negative 21u, plus the 4u here will give me the negative 17u. So you're checking this by FOIL. You know, I did it kind of quickly, but if you're not sure, you know, you'll have to try out the different combinations so you find the ones that work. So when you FOIL the middle terms, the outer and the inner, you add your negative 17u. Once you have this, remember what your goal is. It's really to factor the expression with z's in it. So now we'll back sub here. So if I back sub, remember you're back subbing u equals z squared. So back subbing u equals z squared, this ends up being 3z squared plus 4 times z squared minus 7. Now if this factors further, you'd factor it further at this point. In this case they don't. When you're checking these factors that have two terms, remember you're looking for either a difference of perfect squares or the sum or difference of perfect cubes. This is a difference. This is a perfect square, the z squared, but the 7 isn't. So you can't factor that further. If this was z squared minus 9 though, you would be able to factor that further as a difference of perfect squares. So that's the kind of thing you should be looking out for. Or if they come out to a sum or difference of perfect cubes. In this case it doesn't, so that's how it factors. The only other thing I'll mention is that sometimes people are able to factor from the original problem down to here right away. And if you can see that, that's okay, as long as you understand where the z squareds come from. So multiply the z to the 4th. But it won't always work out that nice. If you were trying to do that with what we had up here, it might not be as easy. So, you know, the quadratic in form is really a way of using a substitution to give us a quadratic expression, and then we factor those. At the very end, you back sub. Don't forget to back sub. It's the most common mistake people make. They'll do everything else correctly, but then at the end they don't back sub in the problem, so they get it wrong. So hopefully this video helps.